Welcome to This Explainer. Today, we're diving straight into the ultimate toolkit for the modern builder, running a fully agentic AI stack right on your local hardware using Gemma 4. We're pulling from Google DeepMind's source material, community benchmarks, and hands-on developer guides to show you exactly how to wield this incredible technology.
All right, let's kick things off with a truly massive number. Over 400 million downloads of previous Gemma models have paved the way for this release. That staggering adoption basically built a vibrant ecosystem, a Gemmaverse, if you will, of over 100,000 fine-tuned variants. But with Gemma 4, the whole paradigm is shifting from simple chat models to fully autonomous agents.
And that brings us to a really crucial starting point for today. The era of relying solely on expensive cloud APIs for capable AI is shifting, and it's shifting fast. According to the AI Builder Club, Gemma 4 is proving that for the vast majority of business and dev use cases, the quality gap between open-weight models and closed cloud models, well, it's just no longer wide enough to justify the privacy trade-offs or the hefty price tags. So here is our roadmap for this explainer. We're going to cover the Gemma 4 revolution, look at its distilled architecture, figure out your hardware and memory needs, walk through a local Ollama setup, troubleshoot some downloads, and finally weigh local versus cloud AI. Let's get right into it.
Section 1. The Gemma 4 Revolution, a new agentic era. Developed by the folks at Google DeepMind, these models are dropping with a highly permissive Apache 2.0 license. Now, why is that such a big deal? It means zero commercial restrictions, no monthly active user caps, and you get full redistribution rights for your products. It essentially hands you complete digital sovereignty over your infrastructure and your data. But what's genuinely groundbreaking here is that these models are built from the ground up to be fully agentic. Back in the day, like a few months ago, you had to rely on messy prompt engineering hacks just to get an open-weight model to use a tool. Not anymore. Gemma 4 features native function calling to output structured JSON consistently. It also introduces an extended thinking mode for multi-step reasoning. Oh, and it does bounding box generation, meaning the model can actually look at a UI screenshot and tell your system exactly where to click. That's a real game changer.
Looking at the lineup, there really is a perfect Gemma 4 model for literally any device you've got. You have the E2B model running in under 1.5 gigabytes of RAM for mobile devices or Raspberry Pi, all the way up to the 31B dense flagship model, which is currently ranking as the number 3 open model globally. But sitting right in the sweet spot for developers is the 26B mixture of experts model. This architecture only activates the specific neural experts it needs for a given task, using just 3.8 billion parameters per token, so you get near flagship reasoning on a standard gaming GPU.
Moving right along to Section 2, Distilled Architecture, Smarter Small Models. To really grasp why these models punch so far above their weight class, we need to talk about knowledge distillation, a technique rooted in the Gemma 2 research. Basically, smaller models aren't just trained longer, they're trained a whole lot smarter. Knowledge distillation replaces that simple next token prediction task with a much richer objective. These smaller models are actually learning from the complex probability distributions computed by a vastly larger teacher model. When you compare a standard from-scratch training approach with distilled training, the difference is kind of wild. It explains exactly how a smaller footprint model can compete with, and honestly, sometimes beat, models 20 times its size. By distilling from a larger teacher, developers simulate training way beyond the compute optimal number of tokens, often over 50 times that optimal quantity. The result? Massive performance gains at sizes you can actually use. All right, Section 3, Hardware and Memory. Let's talk about sizing your model. So what kind of rig do you actually need to run this stuff? Well, you can perfectly match the model to your current hardware. From 1.5 gigabytes of memory for the tiny Edge model up to 24 gigs for the flagship, there's an option for you. If you're using 4-bit quantization, that amazing 26B MOE model fits beautifully into just 8 gigabytes of VRAM. Meanwhile, the default E4B model takes about 9.6 gigabytes when it's fully loaded into memory. But hey, a quick warning from the trenches here. A developer recently shared that running the 26B model on a 24GB Mac Mini with unified memory completely ate up 17 gigabytes. Once they hit it with concurrent requests, it caused heavy swapping and literally froze the entire screen. No bueno for sure. The takeaway? You absolutely have to size your models carefully based on your total system memory, not just the model's resting footprint. That brings us to Section 4, Local Ollama Setup. Time to deploy on your laptop. Let's turn all this theory into action.
Getting started is ridiculously straightforward. For Mac users, simply install Ollama via Homebrew, start the application so the background server initializes, and then run the pull command right in your terminal. By default, pulling Gemma for latest is going to grab the highly capable 8 billion parameter version, bringing down about 9.6 gigabytes of data.
Just a pro tip here, make sure you're running the absolute latest version of Ollama, specifically v0.19 or higher. You want this because it automatically leverages hardware-specific accelerations, like Apple's MLX framework, without you having to configure a single thing. For NVIDIA users, it supports the new NVFP4 format to really reduce memory bandwidth. Plus, the smarter context caching is an absolute lifesaver when you're branching multiple prompts with coding tools like Claude Code.
Okay, Section 5, Download Troubleshooting. Let's fix those slow pulls.
Because let's face it, sometimes the tools just don't cooperate. You might be sitting there wondering, why on earth is my pull command timing out or crawling at a snail's pace? If you're seeing TLS handshake timeouts or unexpected end-of-file errors, especially on those really large model files, the bottleneck might actually be hiding behind a network redirect. It's usually not Ollama servers failing you.
Usually, the culprit is right in your network routing. Here's what's happening under the hood. When you initiate a download, the traffic actually redirects from Ollama's registry over to Cloudflare R2 object storage. If you're running a proxy, custom DNS, or split routing, you need to tweak your settings to allow those r2.cloudflarestorage.com domains. Once you whitelist the actual domain hosting the heavy files, your speed and stability should drastically improve.
Finally, Section 6, Local versus Cloud AI. Choosing your path. Before we wrap things up, let's balance the scales a bit. When should you actually choose this local approach over just pinging a cloud API? Well, local Gemma 4 is completely unbeatable when data simply cannot leave your infrastructure. Think healthcare, finance, or highly strict enterprise environments. It's also brilliant for totally zeroing out API costs on high-volume repetitive tasks. On the flip side, cloud APIs still hold the crown for massively complex, open-ended reasoning problems, or if you just have sporadic workloads and absolutely zero desire to maintain your own inference hardware. With frontier-class reasoning, multimodal vision, and native tool calling now running completely free and completely offline right on your laptop, the barrier to entry is literally gone. You've got the ultimate toolkit right at your fingertips. So the only question left to ask is, what are you going to build with it? Thanks for hanging out with me for this explainer. Keep building, and I'll see you next time.